Enough about the basic data types. We want to build a blockchain. We've had a first look at the data we're going to store in that blockchain, so in the blocks of our blockchain. And later in the course, we'll of course refine that data to reflect a full transaction and not just one word or one number. But for the blockchain, we also need the chain part. And for that, we'll use a list. A list in Python is created with squared brackets. You might know it as an array in other programming languages. A list holds different values. They can be of the same type, so it can be a list of numbers or text, but it can also be a mixed list, like this one. This list has some text, a floating number, a boolean, and even a nested list, which in turn holds some text and a number. Important, the elements in a list are separated with commas, and a list in Python has a certain length which we can get from it. In this case, it would be 4. This gives us the information about how many values are inside of a list. Now, typically, we don't just want to have a list to look at it. We also want to be able to access the elements in our list and change them or output them. And for that, we'll need something which is called the index. Each element in the list has its own index, and here is something very important, which is something you have to memorize. The index in Python lists starts with 0. So we got 0, 1, 2, 3. We got 4 values, but the first value has an index of 0. Therefore, the last value in this case has an index of 3. And accessing values by their index is actually super simple. We take the variable name in which we store the list. Let's say it's my list. And then we use squared brackets and the index to output or to access the value stored at this index. So in this case, it would be some text. Let's have a look at this in practice. Let's say we're creating our blockchain, and therefore I'll create my blockchain variable. And this holds a list, as I said, we created with square brackets, where we now add values. Now, we obviously are building our coin in this course here. So let's say our values are the amounts of coins we're sending with transactions. Right now, we unfortunately have no way of storing the sender and receiver of the coins. We'll do that later in the course, of course, once we had a look at more complex data structures. But the amounts is something we can already store. So let's say in the first transaction, we sent 1 coin. In the second transaction, it's 8.6 coins. In the third transaction, it was 5.1 coin. Of course, no one's stopping us from also adding some text here. So this is really something you as a developer set up. So this is our blockchain. Obviously with hard-coded values, no chance for the user to input his own value. If I hit enter and I then output blockchain like this, here is our list. Now let's say I want to have a look at that second transaction only. Then I can access it with blockchain and then here what? 1. Because remember, the index starts with 0, so the first element, 1 in this case, has an index of 0. If we want to access the second element, 8.6, it's index 1. And correctly, we get 8.6 as an output here. Now we can also use these values in operations. Let's say we're some kind of hacker and we're changing the amount of coins sent in the second transaction. So we could say blockchain plus 2. If we enter this, we get 10.6, but interesting enough, if I then output the blockchain list again, you see here the value is unchanged. Now why is that? The reason for this is that with blockchain 1, we're basically copying the value out of the list. We're not setting up some live connection to the element. So if I add 2 here, I'm adding this to the copied element. And hence, if I do add this here, we correctly get 10.6 because we copy 8.6 out of the list and then we add 2. But the original list, as you can see, is unchanged. Now that copying part is actually something which will become important later again, once we also work with more complex data structures, because there I will show you how you actually have to differentiate between different data types where some are copied automatically whilst others are not. But for now, with strings, numbers, and booleans, it works exactly as I explained it here.